Okay, lesson 5. I told you we'd get nuts in here every so often. Okay? Probably you woke up this morning, you thought it was just going to be a regular day. Come, do lesson 3, keep on, That's why I got to mix it up. You guys, you got to come in here going, okay, what's going down today? I'm ready. Okay? So we're doing lesson 5 today. Why? Because lesson 3, we're skipping. Lesson 4, it's kind of so easy that it's going to insult you. Okay? And I thought, hey, why don't we do the heavy lesson on Friday and the really easy one on Monday? Because the notes take about 10 minutes. The work's going to take about 10 minutes, and then they have the rest of that period to work on their practice test. And then the next day to work on that practice test, and then get 100 on Tuesday. Right? That's my thinking. That's what goes on up here, you guys. While you guys are watching TV and wasting your lives away, amazing things are going on up here. So this is why we're going to do this one today. Now, this one, you're going to actually really have to kind of use your imagination today, because there's some things that aren't going to be so intuitive. Now, I'm going to teach you how to graph reciprocal functions. Okay? Now, when I was in high school, especially in math, I'm like, okay, can you just give me the steps? Can you give me the steps, right? So today I'm going to give you the steps to be able to graph every reciprocal. And they work. Okay? First class, they just worked and worked and worked and worked, and some people got it done, right? Had a few questions, but it wasn't like anarchy, right? When it's anarchy, it's because I didn't do a good job in the notes, okay? So I want to be proactive, right? And I want to make sure I don't rush this. If I actually try to rush this so I can get done 1 minute earlier, it's anarchy, okay? And nobody wants that, especially on a Friday. So I'm just going to ask a few questions before we start, because I need you guys to understand what kind of things we're dealing with when we're talking about reciprocals. Now, when you take the reciprocal of something, what does it mean? What's the reciprocal of 10? 1 over 10. What are you doing? You're flipping it. Now, but that would be 10 over 0. Wouldn't that be 0 over 10? Everything's over 1. So if it's not there, it's a 1, okay? So not like real life. If it's not there, it's usually a 0, okay? How many elephants are there? None. There's 0 elephants. We don't use, there's 1, okay? But 12 is 1 over 12, okay? Now, I want you to picture a number like 10,000. Kind of a big number, right? What happens if you take the reciprocal of that? It's really small. Okay? So, what's a reciprocal, right? It's when A over B, that goes to B over A. Now remember, if it's over 1, like 10, that would be 1/10 if I did the reciprocal, because that's over an imaginary 1. So these are kind of like the rules, right? Whenever you're about to play a game, lay down the rules first, so everyone's not up there going, what are we doing? Okay? So that's the first thing. We know that if we took a number like 10,000, which is a considerably big number, if you took the reciprocal of it, it would be 1 over 10,000. Now that's a pretty necessary concept for this unit, this objective for sure. Now, will a positive number ever become a negative number if you flip it? No, it doesn't. If you take any number in the world and you flip it, yeah, it won't ever become negative. Now that's a huge concept, because some people do think that happens. If you take a negative number and you flip it, it'll never become positive. Okay? You just have to email me, and I will send that student. They haven't figured it out yet. Okay, now the next thing that I want to talk about is, no, and just for the record, right, this would be 0.00001. Okay, that's tiny. That's pretty small. Okay? So, is it safe to say that 0.00001, the reciprocal of that would be 10,000, right? So really, really small numbers, if you take the reciprocal or flip them, they become pretty big numbers. So that's what's going to happen today. The y's are going to trade places. Okay? If you were small, little, teeny, weeny thing on the original graph, you get to become huge on the new graph. If you are huge on the original, when you flip it, it's going to become this tiny point on the new graph. That is really important to know. Now, there's some other kind of important things to know. If 0 falls on the graph, okay, so my original has a 0 on it, a y of 0. What happens? What's the reciprocal of 0? It's 1 over 0, which is undefined. Non-existent, right? There's no number for it. So some reciprocals are going to go bad. 0 over 1 is allowed. 1 over 0 is not allowed. It doesn't exist. Well, how are we going to deal with that? Now, there is 2 numbers, only 2, in the entire numerical system, that if you take the reciprocal of them, they remain the same. 1. 1 works. Okay, if you had 1, right, and you flipped it to, well, that's 1 over 1. Oh, yeah, it just equals 1. Okay, there's only one more. Negative 1. If you take negative 1, well, that's 1 over negative 1, which equals negative 1. All of these 3 concepts on here. Big numbers turn into small numbers. 0 turns into undefined. 1 turns into 1. And negative 1 turns into negative 1. These numbers actually have some important, on a graph, a picture, this would be your asymptote. Okay, spelling's on the t-shirt if you... Because remember, what am I trying to do? I want you to... Here's the picture. Do you know what that would look like in the equation? No, I have no idea. Okay, well then, something went wrong. We lost you along the line. Just like today. Do you know what that picture, like what that means in the algebra? Okay? Now, we haven't named these points yet, though. These points are super important when we're graphing. They have been given, now here's a big word that I challenge you to use it at least one time this weekend, okay? Make somebody think that you're really smart, okay? Those numbers do not change. There's one word for do not change. Okay, so you have a discussion with your parents, they believe something, you have this long discussion, they don't say, I don't care, I still believe this anyway. Then you would say this, Mom, you're just being invariant. Okay, just throw that out there. See what she does. She's like, okay, you know what? Give me 2 minutes, I'm going to Google that. And if it's really bad, you're in big trouble. Okay? Invariant means does not change. Okay? If you were you know, you stole cars for a living, get put in jail, you're in there for a while, you come back out, start stealing cars again, they would say that you've been invariant. Okay? You haven't changed. You're a car thief, you come out a car thief. I mean, you know, your life's been invariant, okay? So, the new word for the day, invariant. Okay? Now, there's a lot of notes to know, but I want to sum it up in that little top part, okay? There's two things that I know from teaching this unit. It's A, keep it simple as absolutely possible, and B, give them really, really clear steps to do this stuff, okay? So I'm going to go through this stuff very, very slowly and very specific, because this is a very tough concept if you just miss one little piece, okay? I'm going to tell you how if you do it this way all the time, you will not get lost. But if you do it in a different order, you 99.9% of the time will not complete the question or even get it close to right. Okay? Now, the first thing I want to do is start doing some graphing. Okay? Because we want to obviously be able to take a picture and apply these things to it. Okay? So let's look at this graph here. Now, see those two graphs? That's the before and the after. If you take the reciprocal of that graph there, x plus 3, and you make it into 1 over x plus 3, it'll look like that. Now, where's your calculator going to fail you? This is when I give you a picture. I call that f of x, and I say give me 1 over f of x. It's going to be like, I can't use my calculator because I don't even know what the equation is for that graph. Okay? So, we're going to do this one, just doing the steps in order, and then we're going to do a couple more as we write the steps. Okay? Because it's important for you to see, how on earth am I going to know how to draw that? Okay? So, just so you're clear, the before, right here, the before, and this is the after. Okay? So I'm going to do all my work here. I'm going to do the entire picture here, and then we're going to look over there and go, that is absolutely amazing. Okay? So, first thing. Man, I'm getting like spam coming in like crazy, and that's never happened before. There's a virus. Okay, anyway. The first thing that you always do is see where the graph goes through the x-axis. What is the y value right here? Guys, this stuff's super important, so watch. What's the y value right here? 0. We're just flipping y values. Okay? X's do not change. Like 1, 0 will turn into 1, undefined. 1, 5 will turn into 1, 1/5. Okay? So make sure you know you're only flipping the y's. Okay? So, you know, we never change the x's, so we're only flipping the y's. Okay, so I'm not trying to use big words here. I'm not trying to like intimidate anybody or confuse anybody by trying to throw some big words around. Only flipping the y's. I mean, I'm keeping that as real as possible. Now, the first thing we always do is we look at where it is going through the x-axis, because that's where y equals 0. If I take the reciprocal of that point, this is -3, 0. The reciprocal of that is -3 does not exist. It's pretty hard to plot -3 does not exist. Okay? So this is what we do. you always do a dashed line right through it. Now, this would have the equation, yes, x equals -3. Okay, that's the equation of that asymptote. Now I know like we have a line for something that doesn't exist. Okay, it's a dashed line because whenever we use a dashed line, it means it is very close to that, but that line doesn't exist. Okay. Now, that is the first thing. The second thing is we have to find out what points on that graph, I'm talking about the black line there, will not change. Which one? Yeah, the y's. So which points would not change on this graph, do you think? Give me the actual point. Okay, -2 and 1. See that point will not change. Does everybody get that? Because 2, 1 will go to 2. Remember, we just flipped the y's. Would become 2, 1. Right? -2, sorry. So that's invariant. That point is not going to change. It is one of the only points on this graph, and the other point will be -4, -1. See, these are and you see, you could just do, right, anything that crosses there, that's going to be invariant. Now those are the points that I need you to get your bearings all the time. Because every time you start to graph, you will start from that point. Your pencil has to be there, then you go. Then you put your pencil back there. Then you go. Then you put your pencil on the next one. You do one thing, next thing you do the other. Now, again, just kind of watch. Now, can everybody please just put their pencil right on top of there? Okay? Now, do you see all of these points here that I'm shading in red? You don't have to do it. I just want you to see. See all those points there? They are all less than 1. Remember, think y values. They're all less than 1, greater than 0, eh? Pretty tiny little numbers. How many numbers are in there? 7? 12? There's an infinite amount of numbers in there, right? So if I take the reciprocal of them, they turn into all of these. Okay? That little, and I know people are saying, how can that little thing turn into a big long line? Well, there's an infinite amount of numbers in there, so they will turn into an infinite amount. Okay? So that red turned into that red when I take the reciprocal. Every single number. Do you see this number right about here? What would you say that number is there? Anyone see my arrow? What would you say that number is? Give me the fraction, half. What would half turn into? 2. So you just come up. Look, look at 2. It's right there. Now what about this guy down here? What do you think he is? He's like maybe 1 over a million, right? What does 1 over a million turn into? Million. It's way up here. It's right up there somewhere. I can't get up there, but it's up there. Okay? Back on the invariant point. Pencil back on there. Now, you see all of these numbers? They turn into small numbers, don't they? They will turn into this. See, the x's stay the same, but the y's trade. So they actually get brought down. Every one of them gets brought down. Every x on there gets brought down. And 1 million was living the dream. Car, big house, pools, everything. Now he's this tiny little insignificant bug. Okay? That would be even happy to swim in a swimming pool right now. Okay? And all those guys that were nothing, now they're these huge numbers because you took the reciprocal of them. They all traded. Okay, all of the y's got flipped. Okay, pencil back on the other invariant point, because I've done all the work on that one now. So your pencil's here. Right there. Okay, pencil's there. Now, see all these points from the pencil to the x-axis? They're all tiny. They're all trading places, and they're going to become. So the way I say it is all the points from the invariant going towards the x-axis turn into points going away from the x-axis. Okay, pencil back on the invariant. Back on. Okay, so you're right there where my arrow is. Now you see all these points here? So I'm trying to show you blue turning into blue, red turning into red. All of these here would turn into, so all the points going away from the x-axis, from the invariant point, will go towards, but never cross, just touch. Okay, just going to touch. Because no number turns into 0. 10 gazillion turns over to 1 over 10 gazillion. It's not a big number, but it's not 0. So you're just going to cruise along that and not really touch the asymptote or the x-axis. Now look at the picture, the after. That's how you get that. Do you see it? Are you not amazed? Are you not amused by this? No? This isn't the coolest thing ever. Okay? Now if you want to graph 1 over x plus 3 in your calculator, make sure you do the x plus 3. See what you're dealing with there. Like what is my calculator going to do? So if I just go 1 divided by x plus 3, okay, zoom 6 it. Now do you see what's happening here? If you have an 84, it doesn't even do this, but do you see how it's putting in an asymptote? It's trying, okay? And then you've got this, and this is supposed to go all the way down here. But it is a limitation of the calculator. It is not going to be able to, it's not going to be able to give you the answer, okay? And this one, you were given the equation. If I just said, hey, there's f of x, there's a picture, draw a new picture, okay? Now, let's go doing some more. We're going to do three more here, or maybe 2 more. Let me see here. Yeah. Okay. We're going to do 3 of these. Now, when you get good at these, I'm not exaggerating. They're about 10 seconds to draw one. Okay? And some of you will be at that stage after today. So, are these hard? No. Not if you know the steps. If you know the steps, they're the same every single time. Okay? Just, there's some little things you need to kind of always be aware of. Okay? Now, let's do example 2 before we do example 1. Example 2, it's got some good stuff in it. Okay, now, does anybody remember what I did first? Okay, so I'm putting down the lines that do not exist. Where will they be at? X-intercepts. Do you see the x-intercepts is here and here? Is R. The x-intercepts are here and here. So, and this is where a ruler comes in handy, or if you just have a dashed line on your smartboard. Okay, it's going to go through there and there. Okay, so you always draw the asymptotes first. And you can never go through asymptotes. Never, never, never. Okay, so this one, we're going to write down the steps as we do the So see under D here, we're going to do our steps. Okay, number 1. Draw vertical asymptotes. Where f of x, that's my original, crosses the x-axis. Okay? AKA, they're the x-ints. So you draw vertical asymptotes where f of x crosses the x-axis. Now, is this something you would do? Maybe you don't have to do this one first, or you could do this one last. Okay, you need to get this done first before you start drawing stuff. Because if you don't have these, you kind of don't have the fences up. These are like the electric fences. You can't touch the electric fences, okay? That's how I think of these things. Have any of you guys ever touched an electric fence? Okay. I have, okay? And, yeah, they scare the crap out of you. They more scare the crap out of you than anything. You're like, I don't even know if that hurt, but man, am I, well, your heart's racing, the whole thing. When I was like a younger kid, and even days like today, I'd have to water the cows. Now that's not, you don't take a sprinkler on them. That means go give them water. So I would always have to jump over this fence, and then I would go, right? And this fence is kind of an electric fence, but it was unplugged, right? Well, why was it unplugged? Because after cattle learn that that's an electric fence, they stay away from it. So you might as well save your power bill and you unplug the fence. Fence still stays there, but it's not electrified, right? Well, unbeknownst to me, one night a calf gets out or something. So my dad has to spend like 3 hours getting this calf in the whole thing. So what does he do? He plugs in the electric fence, okay, the one that I jump over every time I go to water the cows, okay? And so I grab the fence and I'm about to jump over, and it like, like they hurt a cow, okay? I'm like 8 years old, okay? I'm this like little thing, okay? So it's like throws me back, and I was like, okay, whoa. Because I'd never touched electric fence before. Like, I just knew, ooh, electric, it can't be good, right? I watch cartoons. I know what goes on. So, but, yeah, it's something you might want to try. Just once, though, okay? And check current out before you do it. Like, Jurassic Park, that one for the big dinosaur. Probably don't touch that one. A little too much for you. But it is something to write on your resume anyway. So first thing you do is you draw the vertical asymptotes. What's the second thing that I did? I found the invariant points. Now, what are those? Wherever you see a 1 or -1 in the y's. So, do you see here would be 1? Here would be 1? So it's kind of like, you can just, like, if you could just shoot with a laser, that's where we go through. And here, and here. Okay, so we're doing steps, right? So that's number 2. So we draw invariant points. At y equals 1 and -1. Okay, so I got that done. Now what do I do? Come on. Anyone remember? Besides one person. Come on, what did I do next? I didn't stand here, I know that much, but now I am. Huh? Let's be specific. What did I do? Put your pencil on an invariant point. Now just for working together, I want you to put your pencil on this one. Now, in very, very, very light pen or pencil, can you please draw what you think the graph would look like just from that invariant point? There's 3 more to go. I just want you to do this on your own. Like, struggle a little bit. Be out of your comfort zone. Not, okay, we'll do, okay, now it's like, hey, homework, go. And you're like, I don't know what to do. Okay, so now you're going to be making your mistakes. So I want you, you can draw 2 things, right? You want to flip all the ones that are going towards the x-axis to the ones away, and you want to flip all the ones going away to towards. Very lightly. Like so light that you can't even see it light. Because it might be totally wrong, and we don't want to mess up your picture. Okay, everybody sees my arrow up there, right? That's where we're starting from. See the arrow? It needs to be a little bigger, but there it is. See? I'm like a little fly, and I'm flying around this spot. Okay? Now, do you see all these points here? From the invariant, they're going towards the x-axis, right? Therefore, from the invariant, they will go away from the x-axis. Now, will they ever cross that asymptote? Nope. Don't touch the electric fence. Okay? You guys are teenagers. You're good at this. Just get as close as possible to really, really annoy someone, but don't cross the line. Okay? You know where that line is, right? But you guys know how. Right? You know how. Yeah, I know where that is. I'm going to get so close to it. And they're going to freak out, but I'm going to say I didn't cross it. Okay? And there's nothing really they can do about it. Now, what about this part? Now, in our last one, from the invariant point to this one, it went on forever. So I just flipped it. This one doesn't go on forever. It's going to go here and it's going to come back down. So this one's a little bit weird. So y-intercepts are very, very important. This is the y-intercept. What would you say that would be about? Come on, you guys. Let's get through this. What would you say it is? 1.8. So what's 1 over 1.8? It's about a half. So that's going down here. Do you see that? So it's going to turn into like this. Those points there turn into that. Every one of those points got flipped. See, there is no 1 million there, is there? That one goes, and it goes as high as 2, right? What does 2 get when it's flipped? 1 over 2, right? So it's about there. Now, let's go back. Let's go to that other invariant point right beside it. This one here. See it? Right there. So, this is, with my pencil on the invariant point, these that are going towards will turn into points going away. And these points here, those blue, are going to turn into those points there. Okay. So before we do the other points, let's talk about what's going on. We're doing step 3. And this is the best way I could kind of write it. And you know how I like to write it, right? I'm never going to get published in any mathematical journal, okay? I like to write it so it's like simple as possible, okay? So starting from the invariant point, okay, we always want to start from the invariant point. Whatever goes towards whatever goes towards, and I want you to go towards slash away. So whatever goes towards, away on f of x. F of x is the original. Will go away slash towards on 1 over f of x. So starting from the invariant point, you always have to, if you lose your bearings for a second, I'm going to say, put your pencil on the invariant point. You're going to be like, okay, whatever, okay? Then you're going to put it there. And then I'm going to say, okay, on the original, what goes towards? This, okay? Do away. The trading, remember? 1 billion. Now it's like scum of the earth, right? Scum of the earth turns into like mansion on the hill. Now, we've got 2 more invariant points to do. You have to do every invariant point. Let's go over here. See right here? See, these numbers are all very small. They will turn, so they are numbers on the original going towards the x-axis, right? Turn them into points that are going away from the x-axis. Okay? Pencil back on the invariant point. Now, on the original, do you see all the ones going away? They will go to points towards. Now, how do I know not to cross the x-axis? Well, because if those are all negative numbers, aren't they? On the original? Will they ever turn into positive numbers? No. So that's why I can't cross the x-axis. I'm going to get pretty darn close, though. Like 1 trillion, it becomes 1 over a trillion. That's a tiny little thing, right? That's very close to the x-axis. I mean, if there was any argument in life, people are going to say, well, it's 0. Like 1 over a trillion, that's 0. Okay, in probably any argument except for a math class. But that's not 0 in math. Okay? So the other one, pencil back on. Okay? The ones going towards will go away. And the ones going, the blue ones now, back on that invariant, those ones going away will turn into points going towards. And that's what that graph would look like. Okay, so this one, a little faster than the first one. The next 2. But if you follow these steps, number 1, where does this graph go through the x-axis? Name the point. No, that's not a point. What's the point? 2, 0. Do you see this point right here? Draw. If there's a y of 0, that's going through the x-axis, right? So we need to draw our asymptote through there. What do I do next? Okay, invariant points is happen when y equals 1 or negative 1. Is there any negative 1s on this graph? There is 1s, though, here and here. Okay, everybody put their pencil, pen, whatever you got right there. Right there, everyone got? See all these numbers going towards? See them? I'm going to do them in red. See all these numbers towards? Scum of the earth numbers. 1 over a million. 1/2. All those crappy fractions. We all hate fractions. They're all hated, those red things there. But they're all going to turn into things we love. We love a million. I mean, unless it comes to like smacks in the head or something, a million's good, right? Now, pen back on the invariant point always. See, these points here, they're living the dream. Then reciprocal man comes along and says, it's all over, boys. And flips them all, and they become like these insignificant little numbers. Okay? Get to the other side. Pen back on invariant points. Whatever goes towards the x-axis, so from the invariant point, whatever goes towards will go away. Like that's what you have to say to yourself. Towards goes away. Towards what? The x-axis. Okay? Now from the invariant point, whatever goes away will go towards. Now, be very specific. See this point here? That point there? What would be the reciprocal? Like, what is that point? For all intents and purposes, let's call it 3. No, it wouldn't be 3. 2.5, right? What do you think this should be? 1 over 2.5, which is what? Hear me. What's 1 over 2.5? Math enter. Somebody say something. 2 over 5? See? 2.5 became 2 over 5. Because this is 5 over 2. That's what 2.5 is. Became 2 over 5. So sometimes you can figure out the points. If they give you any points, make sure that you put them on your graph. Okay? Okay, one more. Okay, this is the after. So you come across a scene and you see this thing. And people are like, oh, I wonder what it used to be. I bet you it was something, right? I mean, that'd be a pretty safe bet. I bet you it was something. I bet you it was something great. Now it's deflated, lost a job, got no friends, right? But what did it used to look like? Now, it did give us some things. It says the y-intercept is 1/5. Okay? So this would be 0, 1/5. It says the maximum point of this graph. Oh no. It said the maximum point of g of x. Yeah, that is this. Yeah. Wait, this graph right here is -3, 2. Does that make sense? Sure. X is first, right? There's -3, 2. Now, why does this matter? Why do they give me these points? Yeah, because those points are going to be kind of significant when we do reciprocals. Now, the cool thing about a reciprocal is if you take the reciprocal of it again, you get the original. Okay? Like x becomes 1 over x, take the reciprocal of that, becomes x again. So let's take the reciprocal of this. Let's use our steps. Asymptote, what would they be? There isn't one. What? That was our rules. Rule number 1, you took that out. I can't do these. Okay, there are going to be graphs that don't have asymptotes, okay? Like, if you take this graph here, right, it goes like this, or say it went like that. Do you see how they don't have any x? Okay, what about this graph? Here's the graph. It's just a straight line at 2. What's the reciprocal of that? No. Positives never go to negatives. Huh? It is 2 over 1. It would become 1/2, right? If you flip every point on that line, every y, every 2 becomes 1/2, 1/2, 1/2, 1/2. Okay? So some will not have x-intercepts. Don't freak out. Okay? So we don't have x-intercepts. Move to step 2. Where are the invariant points? Does it have them? Yes. Okay? So look at here. invariant point is there and there. Okay, now put your pencil on this invariant point, just like before. Now see these points going towards the x-axis? They will go away from the x-axis. Where do you think it's going to go through? It'll go through at 5. Exactly. So this, see these points going towards? They go all the way to 1/5. Will come all the way up through to 5. So so this becomes 0.5. Okay? Pen back on the invariant point. How dare you take it off? Don't make me come over there, because I will. Now, all the points from there, here I am. See, look at, see all these points going away from the x-axis? Will go towards. But how low should we go? 1/2. Remember, we just flipped the y. So we're going to go to -3, comma 1/2. So where's that point? That's about here, right? We're going to come, oh yeah, this is blue, right? So this is blue. It's going to turn into this. And this is going to be, you can put an arrow up there. There's not a lot of room to write. -3, comma 1/2. Remember, we're flipping every y. Now let's go to the other invariant point. That invariant point, right here. See all of these points going away? Or sorry, towards. Come on, how can you catch me on that? See all these points going towards? They will go away. And there's nothing really significant for me to go through. I'm just going to kind of mirror the other side a bit. Okay, back to the graph, back to that invariant point. See, Shayna, this is what I was talking about. It's that rebellion in you. On the invariant point, okay? All these points going away will turn into points going towards. So that's what you're. Okay? Now wait, just in case you think you might be getting this. Let's try and mess with your heads a bit. It says come up with the equation of that parabola. Okay? Now, you may have seen this formula in your travels. Maybe on vacation this summer. You know, who knows, maybe to school this morning. Anyone out there? Does anyone remember this formula? Yeah? What's P and Q stand for? Vertex. If only I knew the vertex of this original. I do? What is it? Oh, so I know y equals ax minus 1, or no, minus -3, which is plus 3 squared plus 1/2. So I'll just rewrite that so I don't lose anybody. That's x plus 3 squared plus 1/2. Now, which part of that formula do I not know? A. How do I find A? Sub in an xy. A nice point. Any nice points up there? 0.5, right? Okay, so we're going to sub in 0.5. Okay, so y equals, no, not y equals, 5 equals a times 0 plus 3 squared plus 1/2. That is 5 equals 9a plus 1/2, because 3 squared is 9. I'm going to subtract 1/2 to both sides, and I will get 4.5 equals 9a. I'll divide by 9, 4.5 over 9 equals a, which is 1/2. So my equation would be y equals 1/2 a plus 3 squared x plus 3 squared plus a half. A little review for you. Okay? So, I want you to get right at it and get drawn some graphs. If at any point you're just a little bit missing something, please come up and ask. I'm just going to get you back on the steps all the time. You're doing 1 to 11. Okay, 1 to 11. So this is what I didn't want to do on Monday. Yeah, it's not hard stuff, but if you don't know the rules, if you were away today and don't watch the video, I fear for you and your safety. And it's nice, the book at the back has all of the, not on the back, but at the end has all of the pictures drawn. So you can quickly look. Oh, that's 51 minutes of